Okay, so I'm gonna talk a little bit about the lab. Um, here's the report form. It's in Schoology, and it is in Google Slides. So we are going to look at two compounds. One of them is ionic and one of them is covalent. So we're looking at properties. A little bit of an introduction. Ionic compounds have an ionic bond, and they are typically made with a metal and a non-metal. Covalent compounds are covalently bonded together, and they are typically both non-metals. Metalloids are included with non-metals for the purposes of bonding, and we will see that later. For the pre-lab, you probably want to come back and look at this slide. This gives a description of things that we're going to be looking for the two types of compounds. This is the things that we're going to be doing in this lab, and I will turn the camera on so you can see everything. And then slide number 5 is the pre-lab, and we're going to do that now. If you have time left over, you can then go ahead and read through the lab, and you can see what we're going to do. Here's the data table. You can take data while I do it, and then when we're done with that, collecting data, you guys can finish the questions on your own. There might be time in class. We had about 5 or 10 minutes left over in another class, but if we don't, then you can finish this for homework. So here's the pre-lab. Again, it's slide 5. So hopefully everyone's had a chance to download their copy, and make sure you put a name on the front. It does help. I can open it up in Google, and it's nice to be able to see everyone and then look at them. It works out really, really easily. Okay, so I'm gonna put you into 6 groups, and make sure your cameras are on. Discuss the pre-lab with your group, and do that together. It's just gonna be like 4 to 5 minutes, and then I'm gonna bring you all back together. I'd say 4 minutes. Okay, let's do this. Breakout rooms. We'll make 6 groups, 3 to 4 people per group. I'm not gonna pop around in each group. I'm just gonna wait till you guys come back. Okay. Okay. You can call me if you have any questions. That's Hey there. Hold on, let me switch the camera. Okay, I hope that was enough time. I don't have a good gauge. And in class, this kind of thing is, we don't spend a lot of time doing pre-labs and stuff. So I guess, does anyone have any questions? Could everyone figure out the questions? I mean, I'll just do it that way rather than me ask you what your answers were. Does everyone have somewhat an idea of what we're going to look for? If I gave you a mystery solid, which is essentially what we have now, would you have some idea how you would figure out if it was ionic or covalent? Yes? People still coming back. Yes? So give me a thumbs up if you have pretty much some idea of what you would look for. Something? You can. Okay, good. So we're going to do a lot of techniques that we've never done. We've done, I think, a couple things. We've talked about conductivity, but we haven't done conductivity of solution. We'll talk a little bit about melting point. We don't have a good way, well, we do have a good way to get melting point, a precise number, but it takes like a really long time, like an hour to do. So we're not going to spend that kind of time. We're just going to use a hot water bath to figure out if our compound melts high or low. And there's a lot of things that we're gonna do sort of qualitative descriptions of. And let me show you what we have. So everyone has the lab report. I'm not gonna open it on my screen. I'm gonna let you guys look at it there. I know what's in it because I wrote it. So, and I will probably follow the procedure in the order given. So as I talk about it, and I don't have anything labeled here, so I will talk about it as we look at things, because I don't have anything labeled A or B. So, okay, so the first thing we're gonna do is—
You're doing the lab, right? Sorry.
I'm sorry?
You're doing the lab, right?
I am doing a lab. You guys good with that? Yeah, so the lab report that you guys downloaded, I'm gonna do the lab for that. We're gonna look at two compounds and we're gonna look at the properties and figure out which compound is ionic and which is covalent. This is boiling now. I'm gonna turn it down. I want it to boil, but it's gonna all evaporate before we get to it. Okay, so I will work here. Let me put some glasses on. So things we're gonna do, so here are the two solids and I'll show those to you up close. We are gonna observe, the first thing we're gonna do is observe them and use this guy here. It's called a digital microscope. It's like that little handheld microscope. Did you guys use these in biology? Or did you guys use real microscopes, right? Don't you have real ones in bio? Yeah. Anyway, this is a kind of a cheap version of a microscope. It's pretty good. It works for what it's only like 20 bucks on Amazon. It works pretty well. And I will project the image onto my computer and share my screen. I have only one connector for USB for my laptop. So I have to flip the cameras back and forth. So I'll do some flipping. But when I flip to this, just so that's so you know what it is. But first, let's look at these from kind of far away. So here's the two solids. I don't know if it's very bright in here, so you can kind of see. And again, I didn't label them, but this is A. So you can see it in the shadow. So it's like the light shines off of it. It's hard to tell. And it's safe to touch, so I'll just touch it. It's a white solid. It kind of looks like sugar. It's not sugar. I'm here at school, but at the end we'll try to talk about, we'll do some guesses to see if you can figure out what things are. But that's not the goal here. So this is A, and this is B. Also a white solid, and that's on purpose. And again, this is safe to touch. I wouldn't eat anything here, but this is safe to touch. So what I'm gonna do first is put a little bit of A. Do you have a question? I can't hear you. Anyone have any questions? So this is A, and we're gonna look at it through the handheld microscope, and then I'll do B. Here also, again, we're gonna look at both of these. So I'm gonna flip cameras. It's gonna cut out for a minute. All right. Shoot, the camera's been working so well and now it's not. The first time I had to hook it up and re-hook it up like 5 times. So let's see if we can. Hold on. Try. It worked all morning. Just give me a second. Now I'm annoyed. I could put it on my other laptop, but projecting from one laptop to the other was really not very good. Okay, I'm crucially annoyed at this point. Hold on. Let's see. It's all the connectors. I have too many connectors. Let's try this again. I plug everything in over again. Come on. Oof. I hate technology. This is not, it's a Zoom thing. It doesn't, hold on, just give me a minute. Because I can't have it set up ahead of time because I have to unplug one to plug in the other one. Okay, hold on. I have another camera, I'll try that one. I think that's the problem. Yeah, if anyone's Wi-Fi kicks them out, just come on back in. It's been doing that a lot lately. I don't know why. And I'm clearly having technical problems because my camera's not working. All right, hold on. It works so well all morning. There we go. All right. So I'm gonna flip to this guy here, and it's gonna look black until we go up close. So this is, like I said, it's a microscope. It's not as good as the ones used in bio, but if you put it really close, you can, it's pretty amazing actually. There we go. So this was A, which is the one on the left. And it is, they're shiny, they're crystalline. It's a little hard when sometimes they don't, the focus is pretty good. If I try to crush it.
Is this solid A?
This is A, yes. I'm gonna, everything I do, I will tell you if I should do A first for each one of them to make it consistent. If I try to crush it and then look at it, I was trying to do this earlier, you can sort of see, it does crush. I can, you know, I've ruined my beautiful little cubes by crushing it. You can kind of see that. And that is A. Okay. So now B is right next door. Kind of, yeah, that's a good one. It's definitely less shiny. This one here, you can't really tell. If I try to crush it, it's very sticky, if that highly scientific word there. Yeah, it doesn't really crush very well. It kind of just it just sticks to itself if I try to crush it. A little soft. It's definitely not as hard. It's softer. And yeah, also white though, also a white solid. So I'm done with this thing. I'm going to unhook it and hope that my camera is working still. Flip back to the other camera. Okay. Oh, shoot. Every time I unhook it, there's always a chance it doesn't work. Come on. Let's see. Please work. Ah, good. There we go. All right. So now we're back. All right. I'm sorry. I just searched up the wrong one. Oh, it's like the computer's tired. When I get to the end of the day, it doesn't do what it's supposed to. Come on. All right, I'm gonna unhook it from the computer and hook it back in. Sometimes that'll do it. Come on, I need this to work. There we go. I don't know why. Okay, so we are back in business. Here's my document camera. Okay, so those are the two solids that we looked at through the microscope, and everyone just write down whatever observations, you know, as we talk about them. So the next thing that we're gonna do is look at solubility, and then we're gonna measure solubility of both solids, each of them in two different solvents. So we're going to use water, which is, this is just plain old water, which is a polar solvent, and that's on your chart. And then we're going to use hexane, which is a non-polar solvent, sort of like gasoline. Gasoline's probably the closest thing to that. So we're going to put these in test tubes. And I'm not going to use a whole lot. If I use a lot of stuff, then even if it's soluble, it won't look soluble. It won't all dissolve. So just going to add about the size of a pea. That's A. And these aren't labeled, so I'm just going to do them in order. So that is A. I'm going to do A and B both in water first. And I think that this is the order in your lab. So there's B. Do a little bit more. B is really fluffy, so it looks like not as much, but it's actually okay. So I'll put water into both of these. I have stuff everywhere here. And I'm going to fill it up about halfway with water. Each of them. One more in each. All right. So to see if they dissolve, we could wait like half an hour, but it's faster to shake it. So I'm gonna just shake this up. Try not to rattle the camera. So this is A in water. And definitely dissolves. Not quite all dissolved yet, but it's it should all dissolve eventually. Okay, so and for us, for solubility is actually a gradient. You can measure specific solubility. We are going to call it yes or no. Yes, it dissolves. No, it doesn't. We are going to use like a yes no. So that's a yes. So A dissolves in water. And this is B, also in water. You'll notice that it floats, so you might want to make a note of that. And again, I'll shake it. It does not dissolve. So I'll just tell you, I'm not going to hold you in suspense. I could shake it all day and it would never dissolve. So it's going to just sit there, and we're going to come back and look at these later. So So, and use some of them later. So I'm going to leave that here. I'm not going to dump them out. And then I'm going to do A and B in hexane, which is our nonpolar solvent. So again, put A in the first one. And then B in the second one. Okay. And this stuff smells really bad. So in a way, this is good as a demo because I don't know if I would use this if there were 10 different groups doing it, because it would really smell bad. But it's just me here. And I'll turn the fan on once I'm done. I want to fill it about halfway. Run out of stuff. And this smells like gasoline, so it smells, well, it smells like a lab to me, but do a little bit more in each. Okay, so A in hexane, and now I'm going to shake this up again. I'm going to wash my hand. I'm just going to seal it off with my fingers and then wash my hands after. And again, this smells, this also evaporates kind of like gasoline, so I have to work pretty quickly. If I wait long enough, it will all evaporate. And so that is A, and it's, I don't know if you can tell, it's definitely not soluble. It hasn't gone anywhere. It sinks to the bottom, does not float. And then this is B in hexane. Okay. And this is hard to tell right away. There's still some left. The pieces are smaller. I'm gonna keep going. I think I might have put too much in there. Yeah, it's definitely dissolving. Still not all the way there. Let me shake it a little bit more, and then I'm gonna wash my hands. We definitely not want to light a match. I was thinking of doing the melting point with flames, and then I was like, but I can't have flames because I have hexanes and so flammable. Anyway, all right, it definitely is soluble. It's still on the way to dissolving, but again, we are going to label it yes or no, and this is a yes that it's soluble. They're getting smaller and smaller. Eventually, it will totally dissolve. Okay. Okay, so that is solubility. And again, to recap, A and B in water. So you can see them side by side, A and B. A is soluble, B is not. And then A and B in hexane. And again, A is not soluble, we say insoluble, and B is soluble. Okay, so there's a pretty big difference between them, which is good for this. Any questions? Okay, so you want to take data in your data table. The next thing we're going to do is look at conductivity, and solids don't conduct unless they're metal. So I'm not going to try to measure the conductivity of the solids because it's always going to be a no because they're not metallic. But what we are going to do is for the solution of A in water, because a solution is something that's dissolved. So we're only going to test the conductivity of solutions. So A makes a solution in water, we're going to test that one. And then B makes a solution in hexane, we're going to test this one, okay? So they're going to look alike, but they're not alike. So this is going to be A in water, and this is going to be B in hexane. So I'll dump A in water here, which is why in this instructions it says don't dump them out, and that's why, because we're going to use them again. So that's A in water, and this is B in hexane. And we're going to look at conductivity using the same meter. I was going to do this at home, but I brought everything home except I had forgotten the conductivity meter. So I'll fix it so you guys can see it. We're going to use the same conductivity meter that we used for when we did metals and non-metals. So just to remind you what it's measuring, it measures resistance. And I don't know if you can see this, the light is shining on here. So the one means there's no conductivity, which makes sense because my probes are separated. They're not touching anything. If I touch them, the best test, in case you ever want to use one of these, if you touch them to each other, they're metal. So they're definitely going to conduct electricity between them. Hold it still. And it goes down to zero. Sorry, it goes down to zero. Let's see that. Nothing that we do here is going to conduct as well as metal. So it's not going to go to zero. But if we get flashing numbers, if it doesn't stay on 1, then it's a yes, it's conducting electricity. So I'll do A first. So A is in water. And then I guess, can you see the numbers? It's like awkward with the camera here. Let me just make it so you guys can see everything. So I'll put them both. I want to put the probes together in the solution, but make sure that they're not touching each other. And then you're going to watch the numbers on the device. Okay, so they're flashing and they're not 1, which means yes, it's conducting. Not as well as metal, but that's normal. I wouldn't expect it to, but it's definitely conducting electricity. So this is A in water. If we had a better probe, conductivity meters are actually really, really finicky, then we could measure how much it's conducting, but this isn't doing that. This is just telling us, yes, it's conducting electricity. And so now I wiped it off, and now we're gonna put both probes in, this is B in hexane. Can you see the number? And nothing's happening, absolutely nothing. No conductivity, no nothing. So it's not moving at all. So B does not conduct. The liquid that it's in doesn't really matter. It's really about, B is dissolved, but it does not conduct electricity. And so later on, we'll sort of talk about why that is once we figure out what the compounds are. Okay, so any questions about conductivity? Everyone good? All right, now this is now stopped boiling because I turned it down because it was driving me crazy. Turn it back up. Give it a second. We are.
Question.
Sure.
Wait, was B conductive or no?
It was not.
Okay, thank you.
So it stayed on 1, which means resistance is high. It's measuring resistance, and the resistance is very high, which means it's not conducting. So at all, absolutely no conductivity at all. A conducts, but not as well as a metal, just to keep it in perspective compared to what we did last time. Where was my lid? This. Lost it. Okay, so the water is supposed to be boiling. Like I said, I turned it down because it was annoying me. Kept rattling around. Let's see. The question was A. So Shang, the number doesn't matter. It's for A. When we were measuring the conductivity with the meter, it was flashing all over the place. We don't write down the numbers. We just say, yes, it was conducting. It's just a yes or a no. This device that we have here isn't going to tell us exactly how much it's conducting. It's just going to tell us yes or no. Yeah, so just say, yeah, the fact that the numbers were flashing means that yes, it was conducting. So, okay, so that we're done with that. Let's see. So what I'll do is, this is still almost boiling. I'm going to take 2 more test tubes, and they have to be dry. if they're not dry and they have liquid, I could dissolve something and it would look like it's melting, but it's not. So I want to make sure that these are really dry and put more of my solid in there. So A, again, is going to go on the left. I'm going to do quite a bit here so that it's easy to see on the camera. I think in the instructions it says to use a small amount, but I'm the only one doing it, so it's okay. I'm not using up very much stuff. So that's A, and it's definitely a solid, and it's almost boiling. And then B, I'm going to put B in here. B is really fluffy, so it's gonna look like a lot, but it's actually not. So that's B. And again, I'm gonna do A first and then B second. So where's my, shoot, I keep losing stuff. So I'm gonna hold, first thing I'm gonna measure the temperature. This has made me realize that I think our thermometers are all not calibrated very well. So it should be 100. It's not quite boiling. Go a little bit closer. It is 96. We'll let it get, it hasn't gotten above 99. So I think our thermometers are not quite, because it should be 100, but we'll let it get up to 98 or 99, 97. How are we for time? We have about 10 minutes left. We're good. This is the last thing we're gonna do. Let's see. We'll let it really boil. Okay. Come on. 98. All right, now it's 98.7. It's fluctuating. It's good enough. It's boiling. We're good. So I'm gonna take A and then I'm gonna set it in the boiling water. It's really important that I don't get water in here. So I'm gonna try to set it so that the steam doesn't get inside, because it will dissolve it. We already know that. So all I wanna do is try to heat it up. Yes, yeah, you can see it. And I'm gonna leave it there for about a minute. Labs have a lot of wait time in general, which is fine when everyone's here. This feels weird on camera, on Zoom. Okay, what do you guys think? Is it melting? What do you think? At all?
No.
It is not. And to be honest, I could do this all day and it would not melt. Eventually, I'd probably get water in there and it would start to dissolve, but that's a no. So we don't know what melting temperature this would melt at. So what we are gonna do for this is say, we know it doesn't melt below 100. We know it's higher than that. So we're gonna say that it has a high melting point. So you can make a note that it didn't melt in boiling water temperatures, but we're gonna just label that as high. We don't know its actual melting point. So now we're gonna do B. Let's see. And I'll give it a minute. You can actually see it pretty quickly. It starts to look a little wet. I don't know. You guys, it's hard to see up close to the camera. So you can see it's like halfway melted at this point. I'll finish. Yeah, so it didn't even take a minute. Totally liquefied, completely melted. And again, we don't know its actual melting temperature, but we know that it melts lower than 100. And in the world of chemistry, that's low melting. So we just say that it melts at a low temperature, or it has a low melting point. I'm done with that. So we have a few minutes left. So just to show you these again. So big difference in melting temperature, high melting and low melting. If we wait long enough, I don't think it'll happen while we're here, but if we wait long enough, this will cool back down and it will look white again. It'll re-solidify, which is kind of cool. Okay, that's it. Got the camera to work. We're done. Any questions about anything while I have this on? Anyone want to see anything again? Let's see. So we have the solubility. We have the crystals, what they look like, and then the conductivity and the melting. So we covered everything.
Wait, what was the melting point for solid A?
Well, A, it never melted. So
Oh.
we don't know its actual temperature. We just know that it's high melting. That's it.
So do we just write like NA or just high melting?
Right, high melting, yeah. And you could make a note that we know that it melts above 100. I can tell you that it melts way above 100. It's like hundreds of degrees. We don't have any way to test that here. And like I said, I thought about getting a flame, but I can't have a flame around with the solvent that I'm using. So that would not work. I was like, oh, I'll get a Bunsen burner, but I really can't get a Bunsen burner with hexanes around. And I've had them around all day, so there's a lot of vapors and I don't want any flames in here. So anyway, but so what we are gonna do is say high melting and low melting, and we're gonna use the 100 degrees as our point of reference. I will tell you that things that melt high, it's much higher than 100. And things that melt low, anything that melts below 100 is considered very low melting. So that's, so B, oh, and it's turning back into a solid, like you can see it. It's like cooling back down. That's B. So it's re-solidifying. It's still warm a little bit, but it's cooling back down. Yeah, so a lot of these are yes and no things. We're not giving qualifying numbers for things like solubility or melting. We're just saying, yes, it dissolves. No, it doesn't. It melts high, it melts low. So, and again, these are very generalized. All right, we have like just a few minutes left. Does anyone have any questions? You guys can do the questions on your own. Use the introduction. It kind of goes through detail what things to look for if you're not sure. Anyone know what they are? This guy here, the first one, A.
Ionic?
Say it again.
It's an ionic compound?
It's an ionic compound. Yes, you are right. Does anyone know what ionic compound this probably is? I'll give you a hint. I was going to do this at home. I came in last week when I found out we were going to be at home, and I took everything. I forgot the conductivity meter, so I couldn't do it at home. But I didn't bring this home with me because I had some at home already. So
Salt?
it is salt, yes. And actually a couple people said salt. And just to give you a warning though, chemists call all ionic compounds salts. A salt is an ionic compound. So if someone asked me, I would say that this is table salt, and table salt is sodium chloride, or I'd be specific and I would say sodium chloride, which is table salt. So be careful with the word salt. Salt is like a really generic word. I knew what you meant, but just watch that. So we call everything a salt. We have a whole closet full of salts, and it's just like a quick way to say ionic compound. But yes, this is table salt. Anyone? This one's harder to guess. Anyone know what this is? I'll give you a clue. I also had some of this at home. I didn't have to bring any home with me.
Sugar?
It is not sugar. It is not edible. I mean, you could eat it, but you would not want to eat it. It's not really a poison, but it's not really edible. It's not food. I'll give you another hint. It didn't come in this form. I ground it up. I chopped it actually to make it particles. And we use them a lot at this time of year for all sorts of holidays, both Christian holidays and Jewish holidays. At least those are the ones I know of.
Is it wax?
It is wax. It's candle wax. Yes. Someone said weird silicon compound. Yeah, no. Candle wax, which is not weird. It is a soup. Both of these are like the super typical ionic compound. Like if you aren't sure what an ionic compound is going to do, think about table salt. And that is like a poster child for ionic compounds. It does all the things perfectly. So it's a good one. And it turns out that wax is, I kind of have over the years tried to figure out what's the best covalent compound to use for this. I like that it's white and they look the same, even though they're not. But wax does everything right. It dissolves like covalent compounds don't always follow the rules, but wax follows all the rules. So, so it's a good one for this. It's not edible though. So anyway. All right, the bell rang, we're out of time, but if you have any questions, I'm happy to stick around. I'm not going anywhere, but we are done and you can finish the report for homework. And if you have any questions, just ask. All right, have a good day, you guys.
Have a good day.
You good? Do you have any questions?
Can I just share my screen for 1 second?
Can you what?
Can I share my screen?
Sure, let me, I'm gonna pause the video.